Let's continue our lesson. So for this part is for the pressure measurement device. First, you will learn about the barometer. Barometer, atmospheric pressure is measured by a device called barometer. Thus, the atmospheric pressure, often referred as barometric pressure. Barometer is produced by insert a mercury filled tube into a mercury container that open to the atmosphere, as shown below. So when we invert a tube filled with mercury, they will produce a location at sea that is totally vacuum, and as it is totally vacuum, it become totally the pressure become totally zero. Okay, let's start with the first example. Determine the atmospheric pressure at a location where the barometric reading is 740 mm Hg and the gravitational acceleration g is equal to 9.805 meter per second square. Assume the temperature of the mercury to be 10 degrees C, at which its density is 13,570. So you got all the information. To get the pressure, using the same equation, P equal to rho GH, you got the density is 13,570, G is 9.805, and the hash is 0.74 meter. By calculating it, you got the pressure will be is 98.5 kilopascal. Okay, other than to measure the atmospheric pressure at a place, barometer also can be used to measure height. Okay, let's continue to this second example. The basic barometer can be used to measure the height of the building. If the barometric reading at the top and at the bottom of the building are 730 and 755 mm Hg, respectively, determine the height of the building. Assume mercury density is 13,600 kg per meter cube and an average air density is 1.18 kg per meter cube. You know that P at the top is 730 mm Hg and pressure at the bottom of the building is 755 mm Hg. So you can determine the pressure at the top and the bottom of the building. So pressure at the top of the building is P equal to rho GH, rho is 30,600, G 9.81 and H 0.73. You got the pressure at the top of the building is 97,363 Pascal. And then calculate again pressure at the bottom of the building. You know that the hash is 755 mm Hg. So P equal to rho GH, 13,600, 9.81 and times 0.755. You got the pressure at the bottom of the building is 100,729 Pascal. So after you got the pressure at the top and at the bottom of the building, you can find the pressure difference. So pressure difference is 100,729 minus 97,363. We got that the pressure difference is 3,366 Pascal. So why the pressure difference is produced between the bottom and the top of the building? So this pressure difference is caused by the hydrostatic pressure caused by the air and the different H between the top and the bottom of the building. So you can determine now the H of the building by using again P equal to rho GH, but this time using the delta P as P, and hash is the one that we need here. So we get the delta P is 3,366 and density for air is 1.818 kg per meter cube, G is 9.81 and hash is the one that we are searching. So we got now hash equal to 290 meter. Okay, this is another example, but I don't think I want to solve it, but you can solve it later. It's just the same solution, using the same solution procedure used before. Okay, we go to the second device that used for determine the pressure at a location or at the flow. Okay, manometer is commonly used to measure small and moderate pressure differences. A manometer contains one or more fluid, such as mercury, water, alcohol, or oil. So mercury able to measure the pressure in a tank, like the figure at the left, and it also used to measure the flow in a pipeline, as shown in the figure at the right. So how we use a manometer is still the same way, the same equation, P equal to OGH. So for simple manometer, it use only one or two type of liquid, but some manometer use more than one type of liquid. So the solution is simple. You know that P equal to OGH. So no matter how many layers of fluid are used, you can just add the P equal OGH and level by level to get the total P. Okay, we start with the first example for manometer. Okay, a manometer is used to measure the pressure of a gas in a tank. The fluid used has a specific gravity of 0.85 and the manometer column H is 55 centimeter, as shown in the figure 3.19. If the local atmospheric pressure is 96 kilopascal, determine the absolute pressure within the tank. So how to solve it? Okay, we got that the tank, the liquid in the tank is the fluid in the tank is gas. Okay, and then I think I've told you before in the lecture before that as long as in case of a container that contain gas, no matter and then the H is not so, the difference of H is not too high, then we can assume that the pressure all around the container will be the same. So okay, and no matter so for this case, no matter at the top or at the bottom of this pink container, the pressure will be the same. So to get the pressure at any point in the container, so what we need to use now is P equal to OGH. You know that the atmospheric pressure is 96 kilopascal. Okay, PATM is occur here, and then to get the pressure at here is PATM plus OGH. Okay, and then just just include all the data that you have got. 96 kilopascal plus rho equal to 150, G is 9.81, and H is 0.55. So we got the solution is the pressure is 100 kilopascal. Okay, we go to the next example. Okay, this example is multifluid manometer. So for the solution, for the equation, for this type of equation, it's still use the P equal to OGH, but not as direct as the solution before. Okay, I read the question for the second example. The water in a tank is pressurized by air, and the pressure is measured by a multifluid manometer as shown in figure. The tank is located at a mountain at an altitude of 1,400 meters, where the atmospheric pressure is 85.6 kilopascal. Determine the air pressure in the tank if H1 is 0.1, H2 is 0.2, and H3 is 0.35. Take the density of water, oil, and mercury to be 1,850 and 13,600 respectively. Okay, to solve this question, I has give here the 3 steps to solve this type of equation. So the first step is set your solution will be left to right or right to left. You can choose by yourself. And what do you think easier if you choose right to left or left to right? Okay, second, whereas you have choose your solution will be either right to left or left to right, the second thing to do is draw the equation. Okay, for the example here, if I choose right to left to be the solution that I prefer, then the equation will be P2, okay, the pressure at point 2, plus OGH, okay, plus OGH. Why? The difference by the fluid here, by the mercury, we can measure by the different H of H3. Okay, and then plus OGH2. Okay, we now meet with the second fluid, which is oil, and the different pressure is H2. But this time, the second point is higher than the first point. Okay, so as the point is higher at the second point, then we put the negative sign for the H. And then after oil, the third liquid is water. So again, if you see the different H, the second location is higher than the first location. So we still use the negative sign here. So to make it easier, normally just put the negative or positive sign at the front of the equation or on the part. So the equation become P2 plus OGH3 minus OGH2 minus OGH1 equal to P1. Okay, the third step is by solving this equation. So you know that P2 is equal to 0. This one is if I choose to solve for the P gauge. Okay, P gauge for 0.2, as long it is at atmosphere open to the atmosphere, then the pressure will be atmospheric pressure, or P equal to 0 for P gauge, plus okay, the density of mercury is 13,300 times 9.81 for gravity, and H3 is 0.35. Okay, minus 850 times 9.81 times 0.2. 0.2 is the H2, minus 1,000. 1,000 is the density of water, time 9.81 and time 0.1. 0.1 is H1 equal to P1. So we got here P1 equal to 44,400 Pascal. Okay, let's go to the next example. An inverted differential manometer having an oil of specific gravity of 0.8 connected to two different pipes carrying water under pressure. Determine the pressure in pipe B. The pressure in pipe A is 2.0 meter of water. Okay, the solution using the 3 steps. The first step, set your own solution. Will be left to right or right to left. Okay, before I use right to left. So for this question, I will use left to right. Okay, draw the equation. So I start with left to right. So I start with PA plus rho GH1. Okay, the first is the second location is higher than the first location. So we use the negative sign in front of the H1. Plus OGH2, the second point is lower than the first point, so it is positive, plus rho g hash 3. So for this time, the second point is lower than the initial point. So it is positive, equal to PB. Okay, as before, for this negative sign, we move it in front of the equation. Okay, it becomes PA minus rho g H1 plus rho g H2 plus rho g H3 equal to PB. The third step, solve the equation. So it is given that the pressure at pipe A is 2.0 meter of water. Then we got it. We got that PA equal to rho g H. Rho is 1000, G is 9.81, and H is 2. So PA is equal to 19,620 Pascal. We also been given the SG for oil. Okay, they didn't give the density of oil, but they give the specific gravity of oil. So you can calculate the density of the light liquid or the oil. So density equal to specific gravity times 1000. So 0.8 times 1000 is 800 kilogram per meter cube. So okay, now you got the information at each location. PA equal to 19,620 minus rho g hash. For the first liquid here, rho is 1000, okay, because it is water. G is 9.81, and the hash is 0.3. Okay, for the second point, the density is 800, and then G is 9.81, and hash is 0.15. Okay, for the third fluid, the density is 1000 again because it is water. G is 9.81, and the hash is 0.1, so equal to PB. And then by calculate, you get that PB is equal to 18,835 Pascal. Okay, the third example, I think you will have get used to solve any question on manometer. So okay, first, okay, you can pause the YouTube and then start do it with your own first, and then after that you can continue this YouTube if you want to solve it by yourself first. Okay, so the solution for this question, first set your solution either left to right or right to left. So for this question, I think I want to choose for left to right again. Okay, draw the equation. So you can choose any of the solution. For this question, although I choose left to right, you can choose the solution to be right to the left. It's up to you. Any direction for solution will get the same answer. Okay, draw the equation. If I choose left to right, and then PA, we start with PA, and then rho g H1 for the liquid of water, but the second location is higher than the first location, then it is negative hash, and then the second fluid is air. So we know that for air, the different pressure can be negligible. So we can assume that any location, as long the container and as long it is contain air, the pressure will be the same. So plus 0, there is no pressure difference because of air, plus rho g H3 for the third fluid. And then we see here that for the third fluid, the second location is lower than the first location, so it is positive. Okay, so now the equation become PA minus rho g H1 minus 0 plus rho g H3 equal to P3. Okay, the third step, solve the equation. Okay, PA and PP, you don't know what is PA and PB. but the question now is you just need the pressure difference. So don't worry, although it is one equation with two unknown. So PA minus rho G hash, and then the density for water is 1000, G is 9.81, and hash is 0.7, plus 0, plus the third fluid is water again, 1000 times 9.81 plus, okay, the hash is 0.8 plus 0.7 plus 1 equal to PB. Okay, solve it, and then you got PB minus PA equal to 17,658. Okay, we go to the last example for today. Okay, a YouTube differential manometer connecting two pressure pipes at A and B. The pipe A contains a liquid of specific gravity of 1.6 and pressure of 110 kilopascal. The pipe B contains oil with specific gravity of 0.8 and the pressure of 200 kilopascal. Find the difference of pressure measured by mercury. What you need to find out is the hash as the fluid filling YouTube. Okay, so for this question, you got pressure at point A, you got the pressure at point B, but you want to know what is hash. And then for this question, they didn't give you the density, but they give you the specific gravity at the first fluid at pipe A and the fluid at pipe B. So when you got the specific gravity of 1.6, I hope you can automatically calculate it, and then you will know that if the specific gravity is 1.6, the density is 1600. So for the fluid at pipe B, the specific gravity is 0.8, and you know that the density is 0.8 times 1000 become 800 kilogram per meter cube. Okay, let's start our solution using the 3-step. Okay, the first, set your solution. Either you want to make it left to right or right to left. Okay, I still want to use the left to right for this question. You can test by yourself to make the solution from point B to point A, mean right to the left. You should get the same solution, the same answer. Okay, so if I choose from point A to point B or left to right, so the equation become PA plus rho G hash 1 plus rho G hash 2 plus rho G hash 3. So for this time, for the first fluid, the H2 is lower than the first fluid, so it is positive. For the second fluid, is also the second point still below the first point, so it is positive. But for the third fluid, for the second location is higher than the first location, so it is negative. So again, we rewrite the equation become PA plus rho G H1 plus rho G H2 minus rho G H3 equal to PB. Solve the equation. You got almost all the data. So pressure at point A is 110,000 Pascal minus 1,600, the density of fluid in pipe A, times 9.81 plus the hash is 2.6 plus 1. Okay, for the second fluid, the pressure is the density is 13,600, G is 9.81, and hash is, oh, you don't know the hash. Okay, plus the third fluid, the density is 800, G is 9.81, and hash is the combination of 1 and hash. So you just 1 plus hash. Okay, and then you know the pressure at point B. Point B, the pressure is 200,000 Pascal. Okay, solve this equation. You got one unknown and one equation. So by solving it, you can get that the hash is equal to 0.329 meter. Okay, I promise you, previous is the last example. So for the for this example, I won't solve it for you. You can try by yourself if you are interested. Okay, other than barometer and manometer, there are other type of pressure measurement device. Bourdon tube. So Bourdon tube is consists of a hollow metal tube bent like a hook, whose is closed and connected to a dial indicator needle. Okay, second is pressure transducer. Pressure transducer is used various technique to convert the pressure effect to an electrical effect such as change in voltage, resistance, and capacitor. Pressure transducer are smaller and faster, and can be more sensitive, reliable, and precise than other mechanical counterpart. Other type is using the strain gauge pressure transducer. It works by having a diaphragm deflect between two chambers open to the pressure input. So as the diaphragm is elongate, so you can get the strain gauge can measure the elongation, and then will give the pressure at the place. And lastly is the piezoelectric transducer. So we know that piezoelectric material, so it is sensitive to the pressure. So different pressure will give different resistance on the piezoelectric. So it is not resistant. Will give electrical potential. The crystal will produce different electric potential with different pressure. So by calibrating it, you can get the pressure at any place using the piezoelectric material. So this is used as a piezoelectric transducer. Okay, that's all. Okay, one more is the dead weight tester. So the dead weight tester, another type of mechanical pressure gauge. It is used primarily for calibration and can measure extremely high pressure. Okay, because for this one, it uses the oil as the material, and then the pressure will move the plunger here, and then as it moves the plunger, it is also move the piston on the other side, and then we can determine the pressure at the place. The dead weight tester can be used for high pressure measurement, but it is not so sensitive for the low pressure case. Okay, that's all for this week. Okay, see you on the next YouTube. Bye.